Hello there, and welcome to Whispers of Science, where the universe gets intimate and mysteries unfold like gentle bedtime stories. Tonight, we're embarking on a hushed journey through one of the most tantalizing puzzles in all of physics. A question that has captivated brilliant minds and inspired countless science fiction tales. Do wormholes really exist? Now, before we slip through the cosmic rabbit holes of spacetime, I'd love to know where in the world you're watching from and what corner of the universe you call home. Fitting, isn't it? A video about cosmic tunnels, and here we are, scattered across this pale blue dot, each of us peering into the same infinite darkness, wondering if, somewhere out there, reality has shortcuts. If you find this gentle voyage through the cosmos soothing, thought provoking, or simply a nice way to unwind after wrestling with earthly concerns, I'd be ever so grateful if you gave the video a like and perhaps subscribed. It helps this quiet corner of wonder reach other curious souls who might need a peaceful pause with the universe too. Now, I do hope this isn't so fascinating that it keeps you from drifting off, but if it does, well, at least you'll have pondered one of nature's most beautiful mysteries before you rest. So settle in, slow your breathing, and let's begin, because somewhere between theory and imagination, between mathematics and dreams, lies the story of wormholes. Imagine, if you will, folding a piece of paper in half now. If an ant wanted to travel from one edge to the other, it could trudge across the entire surface, taking the long scenic route, or it could slip through a tiny hole connecting the two sides, instantly traveling what should have been a great distance in practically no time at all. This simple paper folding demonstration captures the essence of what physicists call a wormhole, a theoretical tunnel through space-time that could connect distant regions of the universe, or perhaps even different universes altogether. It's a bridge across the cosmic void, a shortcut through the very fabric of reality itself. But here's the beautiful mystery. While our paper and ant analogy is charmingly straightforward, the question of whether these cosmic tunnels, actuals, ally exist in our universe is far more delicate and infinitely more intriguing. Mm. The story of wormholes begins not with telescopes or particle accelerators, but with equations, elegant mathematical poetry written in the language of general relativity in 1916, just 1 year after Albert Einstein published his revolutionary theory describing gravity as the curvature of spacetime. A brilliant Austrian physicist named Karl Schwarzschild was solving Einstein's equations. Schwarzschild was actually serving as a soldier on the Russian front during World War I when he made his remarkable discovery tragically. He would die of an autoimmune disease just months later, but not before gifting humanity with one of the most profound insights into the nature of black holes and potentially wormholes. His solution to Einstein's equations described what we now call a Schwarzschild black hole, but hidden within that mathematical description was something unexpected and rather magical. When physicists examined Schwarzschild's solution more carefully, they discovered that the mathematics seemed to describe not just a black hole, but something far more exotic. The equations suggested that spacetime could be so severely warped that it would create a kind of bridge, a tunnel connecting two separate regions. This wasn't science fiction. This was pure mathematics, flowing directly from Einstein's theory of general relativity, like finding a secret passage drawn in the blueprints of reality itself. But mathematics, as beautiful as it might be, doesn't always translate neatly into physical reality. Just because we can write down equations that describe something doesn't mean that something can actually exist in our universe. It's a bit like being able to write a recipe for a cake made entire lay of moonbeams. The instructions might be mathematically consistent, but the ingredients simply aren't available in any earthly kitchen. The mathematical foundation for wormholes was further developed in 1935 when Einstein himself, along with his colleague Nathan Rosen, published a paper exploring these strange, tunnel like solutions. They called them Einstein-Rosen bridges and showed that according to general relativity, such structures could theoretically exist. The equations were solid, the physics was sound, but there was a rather significant catch. These mathematical wormholes were incredibly unstable. They would collapse almost instantly faster than light could travel through them, making them utterly useless as cosmic highways. It was like discovering the blueprints for a beautiful bridge, only to realize it would crumble the moment anyone tried to cross it. For decades, wormholes remained a fascinating mathematical curiosity studied by theoretical physicists, but dismissed by most as little more than elegant equations with no bearing on physical reality. They were the stuff of blackboard discussions and academic papers filed away in the category of interesting but ultimately irrelevant. Then something remarkable happened. The mathematics began to evolve, and with it, our understanding of what might actually be possible in the strange realm of quantum physics and exotic matter. In 1988, physicist Kip Thorne at the California Institute of Technology began seriously investigating whether wormholes could be made traversable, whether there might be a way to prop them open and keep them stable long enough for something, perhaps even someone, to pass through. Thorne wasn't indulging in science fiction fantasy. He was responding to a request from his colleague and friend Carl Sagan, who was writing a novel called Contact and wanted to know if there was a scientifically plausible way for his characters to travel vast cosmic distances. What Thorne discovered was both encouraging and deeply mysterious. According to Thorne's calculations, it might theoretically be possible to create a stable, traversable wormhole, but it would require something that pushes the boundaries of known physics, something called exotic matter. This isn't the exotic matter you might find in expensive jewelry shops or rare mineral collections. This is matter with properties so strange, so counterintuitive, that it barely seems like matter at all. Exotic matter would need to have negative energy density. Imagine matter that weighs less than nothing, that creates a kind of anti-gravity effect. This bizarre substance would be needed to prop open the throat of a wormhole, preventing it from collapsing and maintaining the cosmic tunnel long enough for travelers to make the journey from one end to the other. Now you might be wondering whether such exotic matter actually exists, and that's precisely where the mystery deepens. Quantum field theory, the branch of physics that describes the behavior of particles and fields at the smallest scales, suggests that negative energy densities might indeed be possible under certain very specific conditions. There's a phenomenon called the Casimir effect, where two parallel metal plates placed very close together in a vacuum will actually attract each other due to quantum fluctuations. This creates regions of space with negative energy density, exactly the kind of exotic matter that might be needed to stabilize a wormhole. It's as if the universe is whispering that yes, perhaps these cosmic shortcuts are more than mere mathematical poetry. But before we get too excited about packing our bags for interdimensional travel, there are still enormous challenges to overcome. First, the amount of exotic matter required to stabilize even a tiny wormhole would be staggering. We're talking about quantities of negative energy that would dwarf the mass energy of entire stars. Second, even if we could somehow gather such exotic matter, there's no guarantee that the resulting wormhole would be safe to traverse the tidal forces, the radiation, the sheer violence of curved spacetime might tear apart anything attempting the journey. And third, there's the question of where these wormholes would lead. A wormhole might connect to another part of our universe, billions of light years away, or it might open into a completely different universe with different physical laws, different dimensions, perhaps even different concepts of time itself. Despite these challenges, the possibility of wormholes continues to captivate both scientists and dreamers. They represent something profound about the nature of reality. The idea that space and time might not be as fixed and unchangeable as they appear, that the universe might have hidden passages, secret doors that could revolutionize our understanding of cosmic travel and our place in the vast web of existence. Some physicists have even speculated that wormholes might occur naturally in the universe, perhaps formed during the chaotic moments following the Big Bang, or created by the intense gravitational fields around black holes. These natural wormholes, if they exist, would likely be microscopic and incredibly short lived, but they would represent a fundamental feature of space-time itself. Tiny too, innels woven into the very fabric of reality. There's also the tantalizing possibility that advanced civilizations, millions of us, might have mass or billions of years ahead the art of wormhole engineering. Imagine beings so technologically sophisticated that they can manipulate space-time itself, creating stable traversable wormholes as easily as we build bridges across rivers. Such civilizations might have turned the galaxy into a vast network of cosmic highways connecting distant star systems and enabling instantaneous travel across what we consider impossible distances. It's a beautiful dream wrapped in rigorous mathematical possibility. As we continue our gentle journey through the mysteries of wormholes, it's worth pausing to marvel at how far human curiosity has taken us from Schwarzschild scribbling equations in the trenches of World War I to modern physicists using supercomputers to model the behavior of exotic matter. We've traced the mathematical threads of possibility through nearly a century of scientific discovery. Each calculation, each insight bringing us closer to understanding whether these cosmic tunnels are mere fantasy or fundamental features of our strange and wonderful universe. The question of wormholes touches something deep within us, the yearning to transcend limitations, to find shortcuts through the vastness of space and time, to discover that reality is far stranger and more interconnected than our everyday experience suggests. Whether wormholes exist or not, they serve as beautiful reminders that mathematics can lead us to ideas so profound, so mind bending, that they challenge our very conception of what's possible in this universe we call home. And perhaps that's the most beautiful mystery of all. Not just whether wormholes exist, but what their mere possibility tells us about the infinite creativity woven into the laws of physics themselves. But let's dive a bit deeper into the mathematical poetry that makes wormholes possible, because understanding the equations is like learning to read the universe's secret language. The key insight comes from something called the Einstein field equations, which describe how matter and energy curve spacetime. Imagine spacetime as a vast rubber sheet stretched taut across the cosmos. Massive objects like stars and planets create dips and curves in this sheet, and these curves are what we experience as gravity. But the equations also allow for more exotic geometries, structures where the sheet doesn't just curve, but actually folds back on itself, creating tunnels that connect distant regions. The mathematics of wormholes involves something called Lorentzian manifolds, which sounds terribly complicated, but is really just a way of describing the geometry of curved spacetime in these mathematical landscapes. Distance and time can behave in ways that seem to defy common sense. Two points that appear incredibly far apart on the surface might actually be quite close if you can slip through the right dimensional shortcut. It's like discovering that your house and your workplace, which seem miles apart by road, are actually separated by just a thin wall if you could somehow step through it. One of the most intriguing aspects of wormhole physics is the relationship between the entrance and exit of these cosmic tunnels. According to the mathematics, the two mouths of a wormhole are connected not just through space, but potentially through time as well. This raises mind bending possibilities that stretch far beyond simple interstellar travel. Imagine a wormhole where one mouth ages more slowly than the other, perhaps because it's been accelerated to near light speed or placed in a strong gravitational field. Such a wormhole could theoretically allow travel, not just between distant places, but between different times, creating a bridge to the past or future. This temporal aspect of wormholes leads us into some of the most profound paradoxes in theoretical physics. If you could travel back in time through a wormhole, you might be able to influence events that led to your own existence, creating logical contradictions that make philosophers and physicists alike lose sleep. Physicists have proposed various solutions to these paradoxes, some involving parallel timelines, others suggesting that the universe has built in mechanisms to prevent paradoxical situations. But the very fact that our best mathematical descriptions of reality allow for such possibilities hints at depths of cosmic strangeness we're only beginning to explore. The search for evidence of wormholes in the real universe has become something of a holy grail for astrophysicists. While we can't yet create them in laboratories, scientists are looking for their signatures in the cosmos. Some researchers have suggested that certain astronomical phenomena might be explained by the presence of natural wormholes. For instance, the mysterious fast radio bursts that occasionally light up radio telescopes around the world. Brief, intense flashes of radio energy from unknown sources. Could these be signals from matter falling through wormhole throats, or perhaps even messages from civilizations using wormholes as communication channels? Another intriguing possibility involves the relationship between wormholes and black holes. Some theories suggest that every black hole might be connected to a corresponding white hole through a wormhole bridge. A white hole would be the theoretical opposite of a black hole. Instead of devouring everything that comes near it, would spew matter and energy outward. While we've never observed a white hole directly, some physicists speculate that they might exist in distant parts of our universe or even in other universes, entirely connected to the black holes we observe through vast cosmic tunnels. The quantum mechanical aspects of wormholes add yet another layer of mystery to these already enigmatic objects. Quantum field theory suggests that the vacuum of space isn't actually empty, but filled with virtual particles constantly popping in and out of existence. These quantum fluctuations might play a crucial role in wormhole physics, either helping to stabilize them or contributing to their collapse. Some physicists have proposed that microscopic wormholes might be constantly forming and dissolving at the quantum level, creating a kind of space time foam where the smooth fabric of reality becomes grainy and turbulent at the smallest scales. If such quantum wormholes exist, they would be far too small and short lived for any practical use, but they might have profound implications for our understanding of fundamental physics. They could help explain some of the mysteries of quantum mechanics, such as the phenomenon of quantum entanglement, where particles separated by vast distances seem to influence each other instantaneously. Perhaps these quantum correlations are mediated by tiny wormhole connections, creating hidden channels of communication that transcend the normal limitations of space and time. The engineering challenges of creating artificial wormholes are staggering beyond imagination. The exotic matter required to prop open a wormhole throat would need to have properties that push against some of the most fundamental assumptions of physics. Not only would it need negative energy density, but it would also need to remain stable under the extreme conditions near a wormhole where space-time itself is twisted into impossible geometries. The amount of energy required to create even a microscopic, traversable wormhole might exceed the total energy output of our Sun over millions of years, making such projects far beyond any conceivable technology. Yet, despite these enormous challenges, some physicists continue to explore the theoretical possibility of wormhole construction. They've proposed various schemes involving rotating black holes, exotic forms of matter, and manipulation of quantum fields. While these ideas remain firmly in the realm of speculation, they represent humanity's perpetual drive to push beyond the boundaries of what seems possible, to imagine technologies and capabilities that would seem like magic to previous generations. Perhaps future civilizations will look back on our current understanding of space-time, the way we look back on ancient maps that showed the Earth as flat, with dragons lurking beyond the edges. The cultural impact of wormholes extends far beyond academic physics departments. These cosmic tunnels have captured the imagination of storytellers, artists, and dreamers, inspiring countless tales of interstellar adventure and cosmic exploration. They represent the ultimate expression of wanderlust, the possibility that no distance is truly insurmountable, no destination too remote to reach. In science fiction, wormholes often serve as plot devices, enabling characters to traverse galactic empires, visit distant worlds, and explore the far reaches of space and time. But beneath the adventure stories lies a deeper resonance. Wormholes speak to our fundamental desire to transcend limitations, to find shortcuts through the obstacles that separate us from our dreams. There's something poetic about the idea that the universe might contain hidden passages, secret doorways that connect distant realms. It suggests that reality is far more interconnected than it appears, that beneath the surface of ordinary experience lies a deeper web of relationships and possibilities. This interconnectedness resonates with many philosophical and spiritual traditions that speak of underlying unity beneath apparent separation. The mathematical possibility of wormholes gives scientific weight to these ancient intuitions, suggesting that separation and distance might be illusions concealing a more fundamental connectedness. As we peer deeper into the cosmic mystery of wormholes, we find ourselves confronting questions that blur the boundaries between science and philosophy, between the possible and the impossible. These theoretical tunnels through spacetime challenge our assumptions about the nature of reality itself, forcing us to consider possibilities that stretch the imagination while remaining grounded in rigorous mathematics. Whether wormholes exist in nature or can be created through advanced technology, their very possibility expands our conception of what the universe might hold in store, reminding us that reality is likely far stranger and more wonderful than we dare to imagine. And as we drift deeper into this contemplation of cosmic shortcuts, we encounter one of the most elegant paradoxes in all of theoretical physics, the grandfather paradox of wormholes. Imagine, if you will, stepping through a wormhole that connects not just two distant points in space, but two different moments in time. You emerge in the past before you were born, and through some cosmic mishap, you prevent your own existence. But if you were never born, how did you travel back in time to prevent your birth? It's a logical loop that ties itself in knots, like a cosmic pretzel that defies all attempts to untangle it. Physicists have spent decades wrestling with these temporal puzzles, and their proposed solutions are almost as mind bending as the paradoxes themselves. Some suggest that the universe has a kind of cosmic editor built into its very fabric, a self consistency principle that ensures paradoxes simply cannot occur if you tried to change the past. You would find that your actions were always part of history, that what you thought was alteration was actually fulfillment. The universe, it seems, might be far more clever at protecting its own narrative coherence than we give it credit for. Others propose that wormhole time travel might create branching timelines, parallel universes that split off from the moment of interference. In this view, your actions in the past wouldn't change your original timeline, but would create a new branch of reality, a different story unfolding alongside your own. It's like a cosmic library where every possible story exists simultaneously, each timeline a different book on the infinite shelves of existence. And perhaps, somewhere in that vast collection, every version of yourself is reading about wormholes and wondering about the nature of time. But let's step back from these philosophical rabbit holes and consider the practical challenges of wormhole detection. How would we actually know if we encountered one of these cosmic tunnels in the wild? The gravitational effects of a wormhole would be subtle but potentially observable. To sufficiently sensitive instruments, a traversable wormhole might bend light in characteristic ways, creating gravitational lensing patterns that differ from those produced by ordinary massive objects like stars or black holes. The throat of a wormhole might act like a cosmic magnifying glass, distorting the light from background objects in ways that could reveal its presence to patient astronomers. Some researchers have proposed looking for wormhole signatures in the cosmic microwave background, the ancient light that fills the universe from its earliest moments. If wormholes formed during the universe's infancy, they might have left subtle imprints in this primordial radiation, like fossil fingerprints pressed into the cosmic clay. These signatures would be incredibly faint, requiring the most sensitive instruments and sophisticated analysis techniques. But they might provide the first concrete evidence that wormholes are more than mathematical curiosities. There's also the intriguing possibility that wormholes might be detectable through their interactions with dark matter, that mysterious substance that makes up most of the matter in the universe but remains invisible to our telescopes. If dark matter particles could travel through wormholes, they might create observable effects patterns in the distribution of dark matter that could reveal the presence of these cosmic shortcuts. It's like trying to deduce the existence of underground tunnels by watching the movement of invisible crowds, a challenging detective story written in the language of gravitational effects and particle physics. The relationship between wormholes and quantum mechanics opens yet another avenue of exploration. Quantum entanglement, that spooky action at a distance that so troubled Einstein, might actually be mediated by microscopic wormhole connections. When two particles become entangled, their properties remain correlated, even across vast distances, as if they were connected by some invisible thread. Some physicists speculate that this thread might be literally real, a tiny wormhole linking the particles through the quantum foam of spacetime itself. If this connection proves true, it would suggest that wormholes aren't just exotic possibilities for future space travel, but fundamental features of reality operating at the smallest scales, governing the behavior of particles and the flow of information through the universe. Every quantum measurement, every collapse of a wave function might involve the opening and closing of microscopic cosmic tunnels, a hidden network of connections that underlies all physical processes. The implications of such a discovery would ripple through our understanding of physics like stones thrown into a still pond. If quantum entanglement operates through wormholes, then perhaps information can travel faster than light through these quantum shortcuts. This wouldn't violate relativity because the information wouldn't be traveling through normal spacetime, but through the curved geometry of wormhole connections. It's like sending a message by folding space instead of crossing it, a cosmic origami that allows communication across impossible distances. But even as we explore these theoretical possibilities, we must remember that wormholes remain firmly in the realm of speculation, beautiful mathematical constructs that may or may not correspond to physical reality. The universe has a history of surprising us with phenomena that seemed impossible until we discovered them, from quantum mechanics to general relativity, from the expansion of the universe to the existence of exoplanets. Reality has consistently proven stranger than our boldest imaginations. Perhaps wormholes will join this list of impossible things that turned out to be true, or perhaps they will remain forever in the category of mathematical poetry. Beautiful equations that describe worlds that cannot be. Perhaps the question itself is less important than what it reveals about the boundless creativity of human curiosity. Our willingness to follow mathematical threads wherever they might lead, even into the deepest mysteries of space-time itself. As we contemplate these cosmic possibilities, it's worth remembering that the journey of discovery often matters more than the destination. The search for wormholes has already led to profound insights about the nature of space-time, the relationship between matter and geometry, and the fundamental limits of what might be possible in our universe. Whether or not we ever find evidence of actual wormholes, the theoretical exploration has expanded our conception of reality and pushed the boundaries of human knowledge into realms that previous generations could never have imagined. And there's something deeply moving about this scientific quest, this patient exploration of mathematical possibilities guided by rigorous logic yet driven by wonder. It represents humanity at its best, our capacity to dream beyond the constraints of everyday experience while remaining grounded in careful observation and logical reasoning. We may be small creatures on a tiny planet orbiting an ordinary star in an unremarkable galaxy, but our minds can conceive of cosmic shortcuts that span the universe tunnels through the very fabric of reality itself. The story of wormholes is ultimately a story about the power of mathematics to reveal hidden possibilities about the universe's apparent willingness to be far stranger than common sense suggests, and about the beautiful mystery that surrounds us on all sides, waiting patiently for curious minds to discover it. Whether these cosmic tunnels exist in reality or only in the realm of mathematical possibility, they serve as reminders that we live in a universe far more mysterious and wonderful than we often realize. So, what would it actually feel like to travel through a wormhole? The mathematics paint a picture both exhilarating and terrifying. Imagine approaching the mouth of one of these cosmic tunnels, watching as the familiar star field ahead begins to distort and stretch. The light from distant galaxies would bend around the wormhole's throat, creating a shimmering ring of distorted images, like looking through the most extraordinary funhouse mirror in the universe. As you drew closer, tidal forces would begin to assert themselves, the difference in gravitational pull between your head and feet becoming increasingly pronounced. But here's where the physics becomes truly mind bending. Inside the wormhole throat, the normal rules of causality might begin to break down. Past and future could become muddled concepts as you traverse regions where time itself flows differently. You might glimpse echoes of your own journey, seeing multiple versions of yourself at different stages of the passage, like reflections bouncing endlessly between cosmic mirrors. The very notion of forward and backward might lose all meaning as space time curves back on itself in impossible geometries. Recent theoretical work has suggested that the interior of a wormhole might be even stranger than early models predicted. Some calculations indicate that the throat could be filled with what physicists call exotic radiation, energy fields with properties so unusual they would make the cosmic microwave background look mundane by comparison. This radiation might carry information from every particle that had ever passed through the wormhole, creating a kind of cosmic memory palace where the history of all travelers is preserved in the fabric of spacetime itself. The exit from a wormhole presents its own set of theoretical challenges. Unlike entering, where you would gradually experience increasing distortion, emergence might be sudden and violent. The mathematics suggests that travelers could be expelled with tremendous force, like cosmic champagne corks popping from a bottle of curved space-time. The destination itself might be unrecognizable, not just because of the vast distances traveled, but because the very passage through the wormhole could have transported you to a region of the universe where the fundamental constants of physics are subtly different. This brings us to one of the most haunting possibilities in wormhole theory. The idea that these cosmic shortcuts might not just connect different places, but different versions of reality itself. Some interpretations of quantum mechanics suggest that wormholes could serve as bridges between parallel universes, alternate realities, where history unfolded differently. In a universe where the laws of physics are almost imagine stepping through a wormhole and emerging but not quite the same as our own, where stars burn with different colors, or where gravity operates according to slightly modified rules. The implications of such interdimensional travel stagger the imagination. You might find yourself in a cosmos where Earth never formed, or where life evolved along entirely different pathways. The night sky might be filled with structures that have no names in our language, phenomena that exist only in universes where the cosmic dice rolled differently during the first moments after the Big Bang. It's a possibility that transforms wormholes from mere transportation devices into windows onto the infinite creativity of existence itself. But let's return to more concrete theoretical ground and consider the energy requirements for creating artificial wormholes. The calculations are humbling in their scope. Creating a traversable wormhole just 1 meter wide would require exotic matter with negative energy, equivalent to the mass energy of Jupiter. That's not just a large number, it's a quantity of exotic matter that would need to be concentrated and controlled with precision that makes our most advanced technologies look like stone tools. The engineering challenges alone would require mastery of physics we're only beginning to glimpse. Yet some physicists have proposed ingenious workarounds to these energy requirements. One fascinating approach involves using the quantum properties of spacetime itself. At the smallest scales, space and time become grainy and uncertain, filled with quantum fluctuations that constantly create and destroy virtual particles. Some theories suggest that by carefully manipulating these quantum fluctuations, it might be possible to create microscopic wormholes that could then be enlarged using techniques that remain purely theoretical but mathematically consistent. Another approach involves the mysterious relationship between information and geometry in quantum mechanics. Recent work in theoretical physics has revealed deep connections between quantum entanglement and the curvature of spacetime. Some researchers speculate that by creating specific patterns of quantum entanglement, it might be possible to induce the formation of wormhole like structures in spacetime itself. It's as if reality could be convinced to create cosmic shortcuts through careful arrangement of quantum correlations, like folding origami from the fabric of existence. The search for natural wormholes has led astronomers to examine some of the most extreme environments in the universe. The centers of galaxies, where supermassive black holes lurk, might be breeding grounds for these cosmic tunnels. The intense gravitational fields and exotic matter conditions near black holes could potentially create the circumstances necessary for wormhole formation. Some scientists have even suggested that the mysterious jets of particles and radiation that shoot from galactic centers might be evidence of matter falling through wormhole connections, emerging in distant parts of the universe as spectacular cosmic fountains. There's also the tantalizing possibility that wormholes might have played a role in the universe's earliest moments. During the period of cosmic inflation, when the universe expanded faster than light itself, The extreme conditions might have spawned countless microscopic wormholes. Most would have evaporated almost instantly, but some might have been stretched and preserved by the rapid expansion, growing into macroscopic tunnels that persist to this day. These primordial wormholes would be fossil remnants of the universe's birth, ancient pathways threading through the cosmic web like hidden arteries in the body of spacetime. The philosophical implications of wormholes extend far beyond their potential practical applications. They challenge our most basic assumptions about the nature of distance, separation, and connectivity. If wormholes exist, then the universe might be far more interconnected than it appears, with every point in space potentially just a tunnel away from every other point. The vast emptiness between galaxies might be an illusion, concealing a network of shortcuts that make the cosmos far smaller and more intimate than we imagine. This interconnectedness resonates with ancient philosophical traditions that speak of the fundamental unity underlying apparent diversity. The possibility that distant regions of the universe might be connected through hidden passages suggests that separation itself might be a kind of optical illusion, a limitation of our perspective rather than a fundamental feature of reality. In a universe threaded with wormholes, the loneliness of cosmic distances would be replaced by an underlying web of connection, making every star a potential neighbor and every galaxy a possible destination. The cultural impact of wormhole theory has been profound, inspiring not just science fiction, but also new ways of thinking about human relationships and communication. If information can travel through quantum wormholes, then perhaps our thoughts and emotions are more connected than we realize. The metaphor of wormhole communication has entered everyday language, describing those mysterious moments when distant friends seem to contact each other simultaneously, or when separated lovers dream the same dreams. Artists have embraced wormholes as symbols of creative possibility, representing the idea that imagination can create shortcuts through the apparent limitations of physical reality. The concept has influenced architecture, with buildings designed to create spatial experiences that seem to fold back on themselves, and music compositions that attempt to capture the sensation of traveling through curved spacetime. Even poetry has been enriched by wormhole metaphors, with writers exploring the idea that language itself might create tunnels between minds, connecting consciousness across the vast distances of human experience. But perhaps the most beautiful aspect of wormhole theory is what it reveals about the human spirit. Our willingness to seriously consider such exotic possibilities, to follow mathematical logic into realms that challenge our deepest intuitions about reality, speaks to something fundamental about human nature. We are creatures who dream of transcending limitations, of finding shortcuts through the obstacles that separate us from our destinations and our dreams. Whether wormholes exist or not, they serve as powerful symbols of our refusal to accept that any barrier is truly insurmountable. They represent the hope that reality is far more flexible and accommodating than it appears, that the universe might contain hidden gifts for those patient and clever enough to discover them. In pursuing the mystery of wormholes, we're not just exploring the nature of space-time, we're celebrating the boundless capacity of human imagination to conceive of possibilities that stretch beyond the horizon of current knowledge. The mathematics that describe wormholes are among the most beautiful in all of physics, elegant equations that seem to dance on the edge between possibility and impossibility. They remind us that the universe speaks in the language of mathematics, and that by learning this language, we can sometimes glimpse truths that transcend ordinary experience. Even if wormholes remain forever theoretical, the equations that describe them stand as monuments to human creativity, mathematical poetry that captures something profound about the nature of existence itself. As we drift further into this cosmic contemplation, there's a particularly enchanting aspect of wormhole physics that deserves our gentle attention. The notion that these theoretical tunnels might not be rare cosmic accidents, but rather fundamental features woven into the very architecture of reality. Some physicists propose that our universe might be riddled with wormholes at every scale, from the microscopic quantum realm to the vast expanses between galaxy clusters, creating what they poetically call the cosmic subway system. Picture, if you will, spacetime not as the smooth fabric we often imagine, but as something more akin to Swiss cheese, perforated with countless holes and tunnels. At the quantum level, these might be so tiny that they wink in and out of existence faster than thought itself, while at larger scales, they could form stable pathways that have persisted since the universe's youth. It's a vision that transforms the cosmos from a collection of isolated islands floating in an ocean of emptiness into something far more intimate and interconnected. This brings us to one of the most delightful paradoxes in theoretical physics: the idea that wormholes might actually be more common than the matter we can see and touch. Dark matter, that invisible substance that comprises most of the universe's mass, remains stubbornly mysterious despite decades of searching. Some creative theorists have wondered whether what we call dark matter might actually be ordinary matter that has slipped through microscopic wormholes, creating gravitational effects in our region of space, while the matter itself resides elsewhere entirely. Imagine entire civilizations whose matter exists in parallel spaces connected to ours only through gravitational threads. Their stars might be invisible to us, their planets undetectable by any telescope, yet their gravitational influence would shape the very structure of galaxies in our observable universe. It's like discovering that your shadow is cast not by your own body, but by someone dancing in an adjacent room, their movements mysteriously synchronized with yours through hidden connections you never knew existed. The quantum mechanical implications of ubiquitous wormholes paint an even stranger picture of reality. If microscopic wormholes permeate the vacuum of space, then every point in the universe might be connected to every other point through an intricate web of quantum tunnels. The empty space between atoms in your body could be threaded with countless tiny shortcuts leading to distant galaxies. The coffee cup resting on your table might be quantum mechanically entangled with matter in the Andromeda Galaxy through wormhole connections, too small to detect, but fundamentally real nonetheless. This quantum foam of microscopic wormholes could help explain some of the deepest mysteries in physics. Why does quantum entanglement seem to operate instantaneously across vast distances? Perhaps because the entangled particles are connected through quantum wormholes that bypass the normal constraints of spacetime. Why do virtual particles appear and disappear so readily in quantum field theory? Maybe because they're not appearing and disappearing at all, but rather slipping back and forth through tiny space-time tunnels, playing an eternal game of cosmic hide and seek. The mathematics describing these quantum wormholes become almost mystical in their implications. They suggest that information, that most fundamental currency of existence, might flow through the universe along pathways that have nothing to do with the speed of light or the distances we measure with our instruments. Thoughts, if they have any physical reality at all, might propagate through wormhole networks that make consciousness far more interconnected than we dare imagine. But let's pause for a moment and consider the sheer audacity of these ideas. Here we are, biological creatures that evolved to hunt and gather on African savannas, seriously contemplating the possibility that reality contains shortcuts through the fourth dimension. Our brains, designed to track the movement of prey and predators, have somehow developed the capacity to envision cosmic tunnels that connect distant regions of spacetime. It's either a testament to the extraordinary power of mathematics or evidence that the universe has a sense of humor about the creatures it has produced. The search for experimental evidence of wormholes has led researchers down some truly fascinating rabbit holes. Some have proposed looking for signatures of microscopic wormholes in particle accelerator experiments. When protons collide at nearly the speed of light, the tremendous energies involved might occasionally create conditions where tiny wormholes could form and decay. The challenge lies in distinguishing these hypothetical wormhole signatures from the countless other exotic phenomena that occur in high energy particle collisions. Other researchers have turned their attention to astronomical observations, searching for gravitational wave signatures that might indicate the presence of traversable wormholes. When massive objects accelerate through curved space-time, they create ripples that propagate at the speed of light, like waves on the surface of a cosmic pond. The gravitational wave observatories that have revolutionized our understanding of black holes and neutron stars might also be capable of detecting the unique signatures of matter falling through wormhole throats or the collision of exotic objects that could only exist in the vicinity of these space-time tunnels. The possibility of wormhole-mediated communication has captured the imagination of both scientists and science fiction enthusiasts. If microscopic wormholes could be created and controlled, they might serve as the ultimate communication channels, allowing instantaneous transmission of information across arbitrary distances. The technical challenges would be staggering, requiring precise manipulation of exotic matter and quantum fields. But the theoretical possibility remains tantalizingly open. Such communication networks could revolutionize our understanding of intelligence and consciousness in the universe. If advanced civilizations have mastered wormhole technology, they might have created galaxy spanning networks that allow instantaneous coordination and collaboration across impossible distances. The search for extraterrestrial intelligence might need to expand beyond radio telescopes and optical surveys to include detection methods for exotic communication channels that bypass conventional spacetime entirely. The philosophical implications ripple outward like waves in a cosmic pond. If consciousness can utilize wormhole networks, then the boundaries between individual minds might be far more porous than we assume. The sense of isolation that characterizes human existence might be an artifact of our limited perspective, concealing deeper connections that operate through channels we haven't yet learned to perceive. Meditation traditions that speak of universal consciousness and interconnectedness might be describing something far more literal than metaphorical. This leads us to one of the most profound questions in all of science. What is the relationship between mind and space time? If information can travel through wormholes, and if consciousness is fundamentally about the processing of information, then perhaps awareness itself might utilize these cosmic shortcuts. The boundaries of the self might extend far beyond the physical limits of the body, threading through wormhole networks that connect every conscious being in a vast web of shared experience. The mathematics of wormhole physics have also inspired new approaches to some of the deepest problems in theoretical science. The relationship between general relativity and quantum mechanics, those two pillars of modern physics that seem fundamentally incompatible, might be reconciled through wormhole geometry. Some theories suggest that the smooth spacetime of general relativity emerges from quantum entanglement networks that operate through microscopic wormholes, like a tapestry woven from invisible threads. These ideas push us toward a vision of reality that is simultaneously more unified and more mysterious than anything previous generations could have imagined. The universe might be far smaller and more intimate than it appears, with every point connected to every other point through hidden pathways that bypass the tyranny of distance. Yet it might also be infinitely larger and more complex, with our observable cosmos representing just one small region of a vast multiverse connected through wormhole networks that span dimensions we can barely conceive. The engineering challenges of creating artificial wormholes have inspired some of the most creative thinking in theoretical physics. While the energy requirements remain prohibitive, researchers have proposed increasingly ingenious methods for reducing these costs. One approach involves using the natural quantum fluctuations of spacetime itself, amplifying tiny virtual wormholes that constantly appear and disappear in the quantum foam. Another involves creating resonance effects that could concentrate exotic energy in precisely the right configurations to stabilize traversable tunnels. Perhaps most intriguingly, some physicists have suggested that advanced civilizations might have learned to create wormholes using information itself as the primary tool. By carefully orchestrating patterns of quantum entanglement and manipulating the flow of information through spacetime, it might be possible to induce the formation of stable wormhole connections without requiring vast quantities of exotic matter. It's as if reality could be convinced to create shortcuts through clever manipulation of its own information processing capabilities. The relationship between wormholes and time travel continues to generate both excitement and consternation among physicists. While the mathematics clearly allow for wormhole configurations that could enable travel to the past, the paradoxes this creates remain deeply troubling. Some researchers have proposed that the universe might have built in protection mechanisms that prevent paradox generating wormholes from forming, while others suggest that time travel through wormholes might be possible but would inevitably create alternate timelines rather than changing the original history. These temporal aspects of wormhole physics touch on some of the most fundamental questions about the nature of causality and free will. If the future can influence the past through wormhole connections, then our conventional understanding of cause and effect might be far too simplistic. Reality might be more like a vast symphony where every note influences every other note, past and future, woven together in harmonies that transcend our linear experience of time. The cultural resonance of wormhole concepts continues to expand, influencing everything from architecture to psychology to spiritual practice. The idea that distant regions of space and time might be intimately connected has inspired new forms of artistic expression that attempt to capture the sensation of folded reality. Musicians compose pieces that seem to loop back on themselves, creating auditory experiences that mirror the mathematical structure of closed time like curves. Visual artists create installations that play with perspective and dimension, inviting viewers to experience spaces that seem to contain more room than their physical boundaries should allow. Even our language has been enriched by wormhole metaphors, with phrases like taking a shortcut through spacetime, entering common usage to describe moments when solutions to problems seem to appear from nowhere, or when insights emerge that connect previously unrelated ideas. The concept has become a symbol for creative breakthrough, representing the possibility that there are always hidden pathways connecting any problem to its solution, waiting for minds clever enough to find them. As we near the end of our gentle exploration, it's worth reflecting on what the mere possibility of wormholes tells us about the nature of scientific inquiry itself. The fact that rigorous mathematics can lead us to concepts so far beyond ordinary experience speaks to something profound about the relationship between mind and cosmos. Our ability to conceive of cosmic tunnels and dimensional shortcuts suggests that consciousness and reality might be far more intimately connected than we typically assume. The equations that describe wormholes are not just abstract symbols on a blackboard, they are maps of possibility, guides to territories of existence that may or may not be physically real, but are certainly mathematically accessible to human thought. In following these mathematical pathways, we engage in a form of exploration that transcends the limitations of space and time, traveling through realms of pure possibility, armed with nothing but logic and imagination. Whether wormholes exist as physical phenomena or remain forever confined to the realm of mathematical poetry, they serve as powerful reminders that reality is likely far stranger and more wonderful than our everyday experience suggests. They challenge us to expand our conception of what might be possible, to remain open to discoveries that could revolutionize our understanding of existence itself. The search for wormholes is ultimately a search for connection, for pathways that could bridge the vast distances that seem to separate us from our cosmic neighbors and from the furthest reaches of space and time. Whether these pathways exist in the fabric of spacetime or only in the realm of human imagination, they represent our deepest yearning to transcend the apparent limitations of physical existence, to find shortcuts through the obstacles that separate us from our dreams and destinations. In contemplating wormholes, we celebrate the boundless creativity of the human spirit, our willingness to follow mathematical logic into realms that challenge our deepest intuitions about the nature of reality. We honor the possibility that the universe might be far more accommodating to our dreams than it initially appears, hiding cosmic shortcuts in the very structure of spacetime itself. And as we drift even deeper into this cosmic meditation, there's a particularly haunting question that emerges from the mathematics, like morning mist. What happens to consciousness itself when it encounters these theoretical tunnels through spacetime? The human experience of awareness, that intimate sense of being present in a particular moment at a specific location, might become something altogether different when filtered through the exotic geometry of a wormhole throat. Imagine the strange sensation of existing simultaneously at 2 points in the universe, your consciousness somehow stretched across impossible distances through a cosmic shortcut. The very notion of here and there might dissolve into something more fluid, more interconnected. Some physicists have speculated that awareness itself might not be confined to the biological boundaries of the brain, but could potentially extend through wormhole networks, like thoughts flowing through hidden neural pathways in the fabric of reality itself. This brings us to one of the most intriguing aspects of wormhole physics, the relationship between information and identity. If your thoughts, your memories, your very sense of self could travel through these space-time tunnels, what would remain constant and what might change? The mathematics suggest that information can be preserved through wormhole transitions, but the subjective experience of that information might be transformed in ways we can barely imagine. You might emerge from a cosmic tunnel, not just in a different place, but as a subtly different version of yourself, carrying memories that have been filtered through the strange geometry of curved spacetime. The quantum mechanical aspects of wormholes add yet another layer of mystery to these already enigmatic phenomena. At the smallest scales, where quantum uncertainty reigns supreme, wormholes might not be stable tunnels at all, but rather flickering possibilities that exist in quantum superposition. A microscopic wormhole might simultaneously connect to multiple destinations, existing in a ghostly state where all possible pathways are equally real until the moment of observation collapses the quantum wave function and selects a single route through space-time. This quantum fuzziness might actually be a feature rather than a bug in the cosmic design. Perhaps the universe uses quantum wormholes as a kind of error correction system, allowing information to flow along multiple pathways simultaneously until the optimal route is selected. It's like having a cosmic postal service that sends every message through dozens of different channels, ensuring that the information arrives, even if most of the pathways fail. The redundancy built into quantum wormhole networks might make the universe far more robust and self correcting than we ever imagined. Recent developments in string theory have added even more exotic possibilities to the wormhole menagerie. In the higher dimensional landscapes that string theorists explore, wormholes might not be simple tunnels connecting 2 points, but rather complex networks that branch and merge like underground river systems. A single wormhole entrance might lead to multiple exits, or conversely, several entrances might converge on a single destination. The topology of these higher dimensional wormhole networks could be so intricate that mapping them would require mathematical tools we haven't yet invented. Some string theorists have proposed that our entire observable universe might be the interior of a vast wormhole, a cosmic tunnel so enormous that we perceive it as flat spacetime. In this view, the Big Bang wasn't the beginning of everything, but rather the moment when our region of spacetime emerged from a wormhole throat, connecting to some unimaginably distant parent universe. The cosmic microwave background radiation that fills our skies might be the faint afterglow of that primordial passage, the thermal signature of our universe's birth through a dimensional shortcut. The implications of this possibility are staggering. If our universe is indeed a wormhole interior, then the laws of physics we observe might be shaped by the exotic matter and energy that lines the tunnel walls. The fundamental constants of nature, those mysterious numbers that determine everything from the strength of gravity to the mass of electrons, might be influenced by conditions in the parent universe that gave birth to our cosmic tunnel. We might be living inside a vast experiment in wormhole engineering, conducted by beings whose existence we can barely conceive. This perspective also suggests that other universes might exist as parallel wormhole interiors, cosmic tunnels branching off from the same higher dimensional space. The multiverse might not be an abstract mathematical concept, but a physical reality composed of countless wormhole chambers, each containing its own version of physics and its own collection of stars, planets, and perhaps even life. The boundaries between these universe wormholes might be permeable under certain extreme conditions, allowing occasional exchanges of matter, energy, or information between cosmic neighbors. The search for evidence of such cosmic scale wormholes has led astronomers to examine the largest structures in the observable universe. The cosmic web, that vast network of galaxy filaments and dark matter strands that spans billions of light years, might actually be the shadow of an even larger wormhole network operating at scales we can barely comprehend. The mysterious dark energy that drives the accelerating expansion of our universe might be leaking through microscopic connections to other cosmic chambers, creating the illusion of empty space filled with repulsive force. But let's scale back down to more intimate possibilities and consider how wormhole physics might influence the evolution of life and intelligence in the universe. If traversable wormholes exist naturally or can be created by sufficiently advanced civilizations, then the entire concept of biological evolution might need to be reconsidered. Life that originated in one part of the universe could potentially spread to distant regions through wormhole networks, carrying genetic information across impossible distances and creating a kind of cosmic biosphere where evolution operates on galactic scales. Imagine ecosystems that span multiple star systems, connected by stable wormhole passages that allow the migration of species across interstellar distances. Predator prey relationships might operate across light years, with creatures from one solar system hunting prey that lives in another. The boundaries between different worlds would become permeable, creating a kind of cosmic Galapagos where evolution experiments with forms and functions that transcend the limitations of individual planets. Intelligence arising in such a universe might develop very different concepts of space, time, and identity. Beings that evolved with access to wormhole networks might think of consciousness as something that naturally extends across multiple locations, perhaps maintaining simultaneous awareness in several star systems. Their literature might describe the loneliness of beings confined to single planets, Their art might explore the beauty of multidimensional existence, and their philosophy might grapple with questions about the nature of unified identity across cosmic distances. The technological implications of wormhole mastery would reshape every aspect of civilization. Transportation would become instantaneous across arbitrary distances, making interstellar empires as manageable as modern nation states. Communication networks could operate in real time across galactic distances, enabling coordination and collaboration on scales that dwarf anything in human experience. Scientific research could be conducted simultaneously across thousands of different environments, with experiments running in parallel across multiple star systems, and the results shared instantaneously through wormhole communication channels. But perhaps more intriguingly, wormhole technology might enable forms of existence that transcend the traditional boundaries between the physical and the digital. If consciousness can be transmitted through wormhole networks as information, then the distinction between biological and artificial intelligence might become meaningless. Minds might migrate between biological bodies, digital substrates, and perhaps even pure energy states, flowing through cosmic networks like thoughts through a vast distributed brain. The cultural evolution of wormhole capable civilizations might follow pathways that seem almost magical to our current understanding. Art forms could involve the manipulation of spacetime itself, with artists creating sculptures from curved geometry and compositions from the harmonics of gravitational waves. Literature might be written in the language of topology, with stories that can only be fully appreciated by minds that can perceive higher dimensional structures directly. Religious and spiritual traditions might evolve to encompass the reality of cosmic interconnectedness, developing practices that utilize wormhole networks for forms of communion and transcendence that we can barely imagine. The concept of pilgrimage might expand to include journeys through multiple dimensions, with sacred sites distributed across the cosmos and connected by pathways that exist outside normal spacetime. Yet, even as we explore these fantastic possibilities, there's something deeply comforting about the fundamental mystery that remains at the heart of wormhole physics. Despite all our mathematical sophistication and theoretical creativity, these cosmic shortcuts continue to elude our complete understanding. They remind us that reality retains an essential element of surprise, that there are always deeper levels of mystery waiting to be discovered by future generations of explorers. The equations that describe wormholes are simultaneously precise and incomplete, like detailed maps of territories that may not exist. They guide our imagination into realms of possibility while remaining humble about the ultimate nature of physical reality. This tension between mathematical precision and ontological uncertainty captures something essential about the human condition: our ability to conceive of possibilities that transcend our current understanding while remaining grounded in careful observation and rigorous logic. The story of wormholes is ultimately a love letter to the power of human curiosity, our willingness to follow mathematical breadcrumbs into the darkest corners of theoretical possibility. Whether these cosmic tunnels exist as physical phenomena or remain forever in the realm of mathematical poetry, they represent our deepest yearning to transcend the apparent limitations of existence, to find hidden connections in a universe that often seems vast and lonely. In contemplating wormholes, we celebrate the strange and wonderful fact that consciousness can conceive of shortcuts through the very fabric of reality itself. We honor the possibility that the universe might be far more interconnected and accommodating than it appears, hiding cosmic pathways in the mathematical structure of spacetime itself. And we embrace the beautiful uncertainty that surrounds these theoretical constructs, finding wonder in questions that may never be fully answered. As we drift toward the gentle conclusion of our cosmic journey, there's something almost musical about the way wormhole physics reveals the hidden harmonies underlying reality. The mathematics describing these space-time tunnels resonates with deeper patterns that seem to echo throughout all of physics, from the quantum realm to the largest scales of cosmic structure. It's as if the universe has composed a vast symphony where wormholes serve as bridges between different movements, allowing themes and melodies to flow between seemingly unrelated sections of the cosmic score. The relationship between wormholes and the fundamental forces of nature continues to surprise physicists with unexpected connections. Electromagnetic fields threading through wormhole throats might create entirely new forms of radiation, while the strong nuclear force could behave in exotic ways when confined to the curved geometry of these spacetime tunnels. The weak force, responsible for certain types of radioactive decay, might operate differently when particles travel through wormhole shortcuts, potentially creating new forms of matter that exist only in the vicinity of these cosmic passages. These interactions between wormholes and the fundamental forces hint at a deeper unity underlying all physical phenomena. Perhaps what we perceive as separate forces are actually different aspects of a single underlying reality, revealed through the lens of wormhole geometry. The electromagnetic field might be intimately connected to gravitational waves through microscopic wormhole networks, while the nuclear forces might represent the effects of matter and energy flowing through quantum tunnels too small to detect directly. But there's also a profound philosophical dimension to wormhole physics that speaks. If these cosmic shortcuts exist, they to questions far beyond the realm of science, challenge our most basic assumptions about causality, identity, and the nature of existence itself. The possibility that effect might precede cause through temporal wormholes forces us to reconsider our understanding of free will and determinism. If the future can influence the past through cosmic tunnels, then perhaps our choices and actions ripple both forward and backward through time, creating loops of causality that make every moment simultaneously a consequence and a cause. This temporal interconnectedness suggests a view of reality where every event is woven into a vast tapestry of mutual influence, where the boundaries between past, present, and future become as permeable as the walls of a wormhole throat. Time might not be the linear river we imagine, flowing inexorably from past to future, but rather a vast ocean where currents flow in all directions simultaneously, connected by hidden channels that allow influence to propagate along pathways that defy conventional understanding. The implications for human consciousness and personal identity are equally profound. If our thoughts and memories could potentially travel through wormhole networks, then the boundaries of the self might extend far beyond the physical limits of our bodies. We might be part of a vast network of consciousness that spans the cosmos, connected to other minds through channels that exist outside the normal constraints of space and time. The sense of isolation that characterizes much of human experience might be an illusion created by our limited perception, concealing deeper connections that operate through dimensions we haven't learned to perceive. This interconnectedness could explain some of the most mysterious aspects of human experience, the uncanny synchronicities that sometimes occur, the moments of inexplicable intuition, the dreams that seem to contain information from beyond our personal experience. Perhaps consciousness naturally utilizes wormhole networks, accessing information and insights from across the cosmic web through channels that exist outside our ordinary awareness. The mathematical beauty of wormhole physics continues to inspire new approaches to some of the deepest problems in theoretical science. The holographic principle, which suggests that all the information in a volume of space can be encoded on its boundary, finds natural expression in wormhole geometry. The interior of a wormhole might be completely determined by information encoded on its throat, suggesting that reality itself might be far more informationally compact than it appears. This holographic nature of wormholes points toward a fundamental relationship between geometry and information that could revolutionize our understanding of reality. Space and time might not be fundamental aspects of the universe, but rather emergent properties of more basic informational structures. Wormholes, in this view, would be natural expressions of the underlying informational architecture of reality, cosmic manifestations of the universe's information processing capabilities. The search for wormhole signatures in the cosmic microwave background has led to increasingly sophisticated analysis techniques that push the boundaries of observational cosmology. Researchers are learning to read the subtle patterns in this ancient light, like astronomers reading tea leaves, searching for the faint imprints that primordial wormholes might have left on the fabric of spacetime itself. These signatures, would be incredibly faint, requiring analysis techniques that can distinguish genuine cosmic anomalies from instrumental noise and systematic errors. But the potential rewards are extraordinary. Detection of wormhole signatures in the cosmic microwave background would not only confirm the existence of these theoretical constructs, but would also provide insights into the fundamental structure of reality itself. We might learn about the conditions that existed during the universe's earliest moments, when the extreme energies and temperatures could have spawned cosmic tunnels that persist to this day as fossil remnants of creation itself. The relationship between wormholes and dark matter continues to generate creative theoretical speculation. Some researchers have proposed that dark matter might not be composed of exotic particles at all, but rather might be ordinary matter that exists primarily in parallel spaces connected to ours through microscopic wormhole networks. The gravitational effects we attribute to dark matter might be the shadows cast by this hidden matter as it influences our spacetime through wormhole connections. This possibility would solve several puzzles about dark matter while creating entirely new questions about the structure of reality. If most of the universe's matter exists in parallel spaces, then our observable cosmos might be just one chamber in a vast multidimensional complex, with matter and energy flowing between chambers through networks of cosmic tunnels. The night sky we observe might be just a small sample of a much larger reality, most of which remains hidden behind the veils of higher dimensional space. The engineering challenges of creating controllable wormholes have inspired increasingly ingenious theoretical proposals. Some researchers have suggested using the properties of quantum vacuum fluctuations to create self sustaining wormhole configurations that require no external energy source once established. Others have proposed using the geometric properties of higher dimensional space to create wormhole networks that exist partially outside our normal three-dimensional reality, making them more stable and easier to maintain. These proposals remain firmly in the realm of theoretical speculation, but they demonstrate the creative power of mathematical physics to envision possibilities that transcend current technological limitations. The fact that such constructions can be described mathematically, even if they cannot yet be built physically, suggests that the universe might contain pathways to capabilities that seem magical from our current perspective. As we approach the gentle end of our cosmic meditation, it's worth reflecting on how the mere contemplation of wormholes has enriched our understanding of reality's possibilities. Whether these space time tunnels exist as physical phenomena or remain forever in the realm of mathematical poetry, they have expanded our conception of what might be possible in a universe far stranger and more wonderful than everyday experience suggests. The equations describing wormholes stand as monuments to human creativity and curiosity, mathematical sculptures that capture something profound about the relationship between mind and cosmos. They remind us that consciousness has the remarkable ability to conceive of possibilities that transcend the apparent limitations of physical existence, to find beauty and meaning in concepts that push the boundaries of imagination itself. In exploring the mystery of wormholes, we've embarked on a journey that is simultaneously scientific and spiritual, mathematical and mystical. We've used the tools of physics to explore questions that touch the deepest aspects of existence: the nature of space and time, the possibility of connection across impossible distances, the relationship between consciousness and cosmos. Whether wormholes exist or not, this exploration has revealed something precious about the human spirit and our place in the vast web of existence. The whispers of science that speak of cosmic shortcuts and dimensional tunnels remind us that reality is likely far more mysterious and accommodating than our everyday experience suggests. They hint at hidden connections that might link every part of the universe to every other part, creating a web of relationships that makes separation and isolation mere illusions, concealing a deeper unity. As you drift toward sleep tonight, perhaps you'll carry with you the gentle possibility that the universe might be threaded with invisible pathways, cosmic shortcuts that connect not just distant places, but distant hearts and minds across the vastness of space and time. Whether these connections exist in the fabric of space time or only in the realm of human imagination, they represent our deepest yearning to transcend the apparent limitations of existence and find meaning in the magnificent mystery that surrounds us on all sides. Sweet dreams, fellow travelers through the cosmic dark, and remember that in a universe where reality whispers of impossible shortcuts and hidden pathways, even the vast distances between us might be just an illusion waiting to be gently unfolded. But before we drift too far into dreams of cosmic tunnels, let's pause to consider what might happen if we actually found one of these theoretical passages. The practical implications of discovering a real wormhole would ripple through human civilization like waves through still water, touching everything from our understanding of physics to our most fundamental assumptions about our place in the universe. Imagine the moment when astronomers first detect the unmistakable gravitational signature of a wormhole throat, that subtle distortion in space-time that could only be caused by exotic matter holding open a tunnel through the fabric of reality itself. The discovery would likely come not as a dramatic eureka moment, but as a quiet anomaly in data, a pattern that doesn't quite fit existing models, gradually revealing itself through patient analysis and careful observation. The first confirmed wormhole might be detected through its gravitational lensing effects, the way it bends and distorts the light from background stars and galaxies. Unlike the smooth, predictable lensing caused by ordinary massive objects, a wormhole's signature would be subtly different, creating optical distortions that hint at the presence of negative energy and curved spacetime geometries that shouldn't exist according to our current understanding of cosmic architecture. Or perhaps the discovery would come through gravitational wave astronomy, those exquisitely sensitive instruments that can detect the tiniest ripples in space-time itself. A wormhole might announce its presence through gravitational waves unlike anything we've observed before, patterns that speak of matter and energy flowing through impossible geometries, creating symphonies of distorted space-time that would make even the most exotic black hole collisions seem mundane by comparison. The scientific response would likely be a mixture of excitement and extreme caution. Extraordinary claims require extraordinary evidence, and the detection of a wormhole would certainly qualify as extraordinary. Teams of physicists and astronomers would spend months or years verifying the observations, ruling out instrumental errors, alternative explanations, and the ever present possibility that what appears to be a cosmic shortcut is actually some previously unknown but perfectly ordinary astrophysical phenomenon. But let's imagine that the evidence proves conclusive, that humanity has indeed detected its first genuine wormhole. The implications would unfold slowly, like ripples spreading outward from a stone dropped in a quiet pond. The discovery would fundamentally alter our understanding of space-time itself, confirming that the universe is far stranger and more malleable than even our most adventurous theories had suggested. Or the wormhole might be located thousands or millions of light years away, far beyond any hope of direct exploration with current technology. Yet even observing it from such vast distances would provide invaluable insights into the nature of exotic matter, the behavior of curved space-time, and the fundamental limits of what's possible in our universe. Every photon of light that reached us from the vicinity of the wormhole would carry precious information about conditions near the throat, data that could revolutionize our understanding of physics. Scientists would immediately begin searching for more wormholes, developing new detection methods and analysis techniques designed to identify these cosmic rarities. The discovery of one wormhole would suggest that others might exist, perhaps hidden in the data we've already collected, but haven't yet learned to interpret correctly. Astronomical surveys would take on new urgency, scanning the sky for the subtle signatures that might reveal a network of cosmic shortcuts threading through our galaxy and beyond. The theoretical implications would be equally profound. The existence of even one stable, naturally occurring wormhole would validate decades of speculative physics and open entirely new avenues of research. Physicists would race to understand how such structures could form and persist, what kinds of exotic matter might stabilize them, and whether the same processes that created one wormhole might have created many others throughout the universe's history. But perhaps the most tantalizing question would be whether the discovered wormhole is traversable, a wormhole that allows the passage of matter and information would represent far more than just a curiosity for theoretical physics. It would be humanity's first glimpse of a genuine cosmic highway, a shortcut through space-time that could potentially revolutionize our relationship with the universe itself. Even if the wormhole proved to be non traversable, collapsed, or filled with deadly radiation, its mere existence would transform our understanding of cosmic possibilities. We would know with scientific certainty that the universe contains structures that transcend our everyday experience of space and time, that reality is fundamentally more flexible and surprising than we had dared to hope. The cultural and philosophical impacts would be equally significant. The confirmation that wormholes exist would validate science fiction's most cherished dreams while simultaneously making them seem quaint and limited. Writers and artists would struggle to imagine possibilities that match the strangeness of reality itself. The cosmic shortcuts that have long captured human imagination would no longer be fantasy, but established fact, opening new frontiers for both scientific exploration and creative expression. Religious and spiritual communities might find in wormholes a kind of scientific validation for ancient teachings about the interconnected nature of existence. The idea that distant regions of the universe could be intimately connected through hidden pathways would resonate with mystical traditions that speak of underlying unity beneath apparent separation. Some might see in these cosmic tunnels evidence of divine architecture, while others might find in them confirmation that consciousness and cosmos are far more deeply intertwined than materialist philosophies suggest. The discovery would also raise profound questions about the prevalence of intelligence in the universe. If wormholes can occur naturally, then advanced civilizations might have learned to detect and utilize them millions or billions of years ago. The apparent silence of the cosmos, the famous Fermi paradox that asks where all the extraterrestrial civilizations are hiding, might be explained by the existence of communication and transportation networks that operate through channels we've only just learned to recognize. Perhaps the galaxy is actually bustling with activity, but most of it flows through wormhole networks that bypass normal spacetime entirely. Civilizations might have abandoned electromagnetic communication in favor of instantaneous information transfer through microscopic wormhole channels. Interstellar travel might utilize cosmic shortcuts that make the vast distances between stars irrelevant, creating galactic communities that exist in parallel to our isolated corner of ordinary spacetime. The economic implications of wormhole discovery would unfold over decades as humanity began to grasp the full potential of these cosmic structures. Even non traversable wormholes might serve as natural laboratories for studying exotic physics, providing insights that could lead to revolutionary new technologies. The unique conditions near wormhole throats might enable forms of energy production materials science, and information processing that are impossible in ordinary spacetime. If the wormhole proved to be traversable, or if humanity learned to create artificial wormholes based on observations of natural ones, the economic and social transformations would be unprecedented. The concept of distance would lose much of its meaning, making interstellar trade and commerce as routine as international shipping is today. Resources from distant star systems could be transported instantaneously, while colonization efforts could establish footholds across the galaxy without the centuries long journeys that current physics would require. But such transformations would also bring new challenges and ethical dilemmas. Who would control access to wormhole networks? How would humanity prevent these cosmic shortcuts from being weaponized? The ability to transport matter instantaneously across galactic distances could enable forms of warfare and terrorism that would make current global conflicts seem limited and manageable by comparison. The social implications of wormhole technology would be equally complex. Families and communities could remain connected across impossible distances, but the traditional ties that bind societies together might weaken as physical location loses its significance. Cultural exchange could accelerate to unprecedented levels, but so could cultural homogenization as the barriers that allowed diverse societies to develop independently begin to dissolve. Educational systems would need to be completely reimagined to prepare future generations for life in a wormhole connected universe. Students might attend classes taught simultaneously across multiple star systems, collaborating on projects with peers from civilizations they've never physically visited. The concept of local expertise would expand to include knowledge from across the galaxy, while the meaning of home might become far more fluid and complex. The philosophical implications would challenge our most basic assumptions about identity and continuity. If consciousness can travel through wormhole networks, what happens to the self during the journey? Are you the same person who emerges from a cosmic tunnel, or has the passage through curved space time fundamentally altered your nature? These questions, once confined to the realm of philosophical speculation, would become practical concerns requiring legal and social frameworks that don't yet exist. The relationship between humanity and artificial intelligence might also be transformed by wormhole physics. If consciousness can be transmitted through these cosmic channels as information, then the boundaries between biological and digital intelligence might become meaningless. Minds might migrate freely between organic brains, quantum computers, and perhaps even pure energy states, creating forms of existence that transcend traditional categories of life and consciousness. As we contemplate these possibilities, it's worth remembering that the discovery of even one wormhole would represent just the beginning of humanity's journey into a far stranger and more wonderful universe than we currently imagine. Each new detection would raise fresh questions, reveal new mysteries, and open pathways to forms of existence and experience that stretch beyond our current capacity to envision. The whispers of science that speak of cosmic shortcuts would become a chorus of confirmed discovery, transforming humanity from a species confined to a single world into potential citizens of a universe where distance is negotiable and separation is optional. Whether such transformations would ultimately prove beneficial or catastrophic would depend largely on how wisely we navigate the transition from our current cosmic isolation to membership in whatever larger community might await us on the far side of spacetime's hidden passages. Yet, even as we dream of such possibilities, there's something comforting about the fact that wormholes, whether they exist or not, remind us that the universe is likely far more accommodating to consciousness and curiosity than it initially appears. The mathematical possibility of cosmic shortcuts suggests that reality might be constructed with intelligence and exploration in mind, that the apparent barriers separating us from distant realms might be more like veils waiting to be gently lifted than walls designed to confine us forever. And so, as we drift toward the end of our cosmic meditation, we're left with a beautiful paradox. The search for wormholes is simultaneously a journey inward and outward, an exploration of the universe's hidden architecture, and an investigation of consciousness's capacity to conceive of possibilities that transcend immediate experience. Whether these cosmic tunnels exist in space time or only in the realm of mathematical imagination, they represent something precious about the human condition, our refusal to accept that any frontier is truly final, any distance truly insurmountable. In the gentle mathematics that describe wormholes, we find echoes of our deepest longings for connection, transcendence, and discovery. The equations whisper of shortcuts through the cosmic dark, of pathways that could carry us beyond the apparent limitations of existence itself. And perhaps that's the most beautiful aspect of this scientific mystery. Not whether wormholes are real, but what their mere possibility reveals about the infinite creativity woven into the fabric of reality and the boundless capacity of consciousness to envision and perhaps even create the very connections it seeks. As we settle deeper into this gentle contemplation of cosmic mysteries, there's something almost dreamlike about how wormhole physics blurs the boundaries between the possible and the impossible. These theoretical constructs exist in a realm where mathematics meets imagination, where rigorous equations describe phenomena so exotic they seem to belong more to poetry than to science. Yet here they are, emerging naturally from the same mathematical framework that describes the orbit of planets and the bending of light around massive stars. The relationship between wormholes and the fundamental structure of reality continues to reveal itself in unexpected ways. Recent theoretical work has suggested that these cosmic tunnels might not be rare anomalies, but rather essential features of spacetime itself, woven into the very fabric of existence, at scales both microscopic and cosmic. At the quantum level, virtual wormholes might constantly flicker in and out of existence, creating a kind of space-time foam where the smooth geometry we observe emerges from countless tiny fluctuations in the underlying structure of reality. This quantum perspective transforms our understanding of what it means for space to be empty. The vacuum between atoms in your coffee cup might be permeated by microscopic wormhole connections, invisible threads linking every point in space to every other point through pathways that exist outside our normal three-dimensional experience. These quantum tunnels might be so small and short-lived that they have no practical effect on everyday phenomena. Yet their collective presence could influence the fundamental properties of matter and energy in subtle but profound ways. The mathematical elegance of wormhole solutions continues to inspire new approaches to some of physics' deepest puzzles. The relationship between quantum mechanics and general relativity, those two pillars of modern science that seem fundamentally incompatible, might find resolution through wormhole geometry. Some theories suggest that the smooth spacetime of Einstein's relativity emerges from networks of quantum entanglement that operate through microscopic wormhole connections, like a tapestry woven from invisible threads of correlation and connection. This quantum origin of spacetime would mean that the universe's most basic properties arise from relationships rather than substances, from connections rather than components. Space and time themselves might be emergent phenomena, arising from deeper patterns of information exchange that flow through wormhole networks, too small to observe directly, but fundamental enough to shape the nature of reality itself. It's a vision that transforms the cosmos from a collection of separate objects moving through empty space into something more like a vast neural network, with consciousness and matter interconnected through channels that transcend ordinary physical boundaries. The implications for our understanding of consciousness itself are particularly intriguing. If information can flow through wormhole networks, and if awareness is fundamentally about the processing and integration of information, then perhaps consciousness naturally utilizes these cosmic shortcuts. The boundaries of individual minds might extend far beyond the physical limits of brains, threading through wormhole connections that link every conscious being in a web of shared experience and mutual influence. This interconnected view of consciousness resonates with mystical traditions that speak of universal awareness underlying individual identity, but it grounds these ancient insights in the rigorous mathematics of modern physics. The sense of separation that characterizes much of human experience might be an artifact of our limited perception, concealing deeper connections that operate through dimensions we haven't learned to access consciously. Meditation practices that speak of dissolving the boundaries of self might be describing something far more literal than metaphorical, actual shifts in awareness that tap into the wormhole networks that connect all minds across space and time. The search for wormhole signatures in astronomical observations has become increasingly sophisticated, utilizing techniques that push the boundaries of what's possible with current technology. Radio telescopes scan the cosmos for the subtle distortions in electromagnetic radiation that might indicate matter falling through wormhole throats, while gravitational wave detectors listen for the space-time ripples that could be produced by exotic matter configurations. Every anomaly in the data is carefully analyzed, every unexplained signal scrutinized for patterns that might reveal the presence of these cosmic shortcuts. But perhaps the most promising avenue of research involves studying the quantum vacuum itself, that apparently empty space that quantum field theory reveals to be alive with virtual particles and energy fluctuations. Some physicists have proposed that careful analysis of vacuum fluctuations might reveal the signatures of microscopic wormholes, tiny tunnels that exist for mere fractions of a second but leave measurable imprints on the quantum fields that permeate all of space. These signatures would be incredibly subtle, requiring experimental techniques that can distinguish genuine wormhole effects from the countless other quantum phenomena that contribute to vacuum noise. The technological implications of mastering wormhole physics would extend far beyond transportation and communication. The exotic matter required to stabilize these cosmic tunnels might enable entirely new forms of energy production, materials with properties that seem to violate conservation laws, and information processing systems that operate through channels that bypass the normal limitations of space and time. The ability to manipulate spacetime geometry directly could revolutionize manufacturing, allowing the creation of objects with internal geometries that are larger than their external dimensions, like cosmic versions of the TARDIS from science fiction. Medical applications might be equally revolutionary. If consciousness can indeed utilize wormhole networks, then certain neurological conditions might be understood as disruptions in these quantum connections rather than purely biological malfunctions. Therapeutic approaches could potentially involve techniques for repairing or enhancing wormhole connections in the brain, opening new possibilities for treating conditions that currently seem intractable. The boundary between neuroscience and physics might dissolve entirely as we learn to work with the quantum foundations of awareness itself. The cultural evolution of a wormhole capable civilization would likely follow trajectories that seem almost magical from our current perspective. Art forms could emerge that manipulate space-time directly, creating sculptures from curved geometry and compositions from the harmonics of gravitational waves. Literature might be written in the mathematics of topology, with stories that exist in higher dimensional spaces and can only be fully appreciated by minds capable of perceiving multiple spatial dimensions simultaneously. Educational systems would need to be completely reimagined to prepare students for existence in a universe where the traditional boundaries of space and time have become negotiable. Children might learn to think in terms of multidimensional relationships from an early age, developing intuitive understanding of concepts that currently require advanced mathematical training to grasp. The very notion of local knowledge would expand to encompass information from across the cosmic web, making every classroom a potential gateway to the accumulated wisdom of galactic civilization. The philosophical implications ripple outward like waves in a cosmic pond, touching questions about the nature of identity, causality, and free will. If the future can influence the past through temporal wormholes, then our understanding of cause and effect might need fundamental revision. Perhaps every moment exists in a state of mutual influence, with every other moment, past and future, woven together in patterns that transcend our linear experience of time. The choices we make today might be simultaneously influenced by and influential upon decisions that won't be made until tomorrow, creating loops of causality that make traditional notions of determinism and randomness seem quaint and oversimplified. This temporal interconnectedness suggests a view of reality where responsibility extends both backward and forward through time, where every action ripples through the cosmic web of causation in ways that affect both ancestors and descendants. The ethical implications are staggering, forcing us to consider how our choices might influence not just future generations, but past ones as well, creating a kind of temporal stewardship that encompasses all of history simultaneously. The relationship between individual and collective consciousness might also be transformed by wormhole physics. If minds can connect through these cosmic networks, then the boundaries between self and other might become as fluid as the geometry of space-time itself. Collective intelligence might emerge naturally as individual consciousnesses learn to coordinate their activities through wormhole connections, creating forms of group awareness that transcend the limitations of biological brains while preserving the unique perspectives that individual experience provides. Yet, even as we explore these exotic possibilities, there's something deeply human about our fascination with cosmic shortcuts and hidden connections. The appeal of wormholes taps into ancient yearnings for transcendence, for pathways that lead beyond the apparent limitations of physical existence. They represent the hope that reality is far more accommodating to consciousness and curiosity than everyday experience suggests, that the universe might contain hidden gifts for those patient and clever enough to discover them. The mathematics that describe wormholes stand as monuments to human creativity, elegant equations that capture something profound about the relationship between mind and cosmos. Whether these theoretical constructs correspond to physical reality or remain forever in the realm of mathematical poetry, they demonstrate the extraordinary capacity of consciousness to conceive of possibilities that stretch beyond immediate experience, to find beauty and meaning in concepts that push the boundaries of imagination itself. As we drift deeper into this cosmic meditation, it's worth reflecting on how the mere contemplation of wormholes has enriched our understanding of what might be possible in a universe far stranger and more wonderful than we dare to hope. The whispers of science that speak of cosmic shortcuts and dimensional passages remind us that reality is likely far more mysterious and interconnected than our everyday experience reveals. Perhaps the most beautiful aspect of wormhole physics is not whether these cosmic tunnels exist, but what their mathematical possibility tells us about the nature of existence itself. The equations suggest that the universe might be constructed with consciousness in mind, that the apparent barriers separating us from distant realms might be more like veils waiting to be lifted than walls designed to confine us. In following these mathematical pathways into the deepest mysteries of space-time, we engage in a form of exploration that transcends physical limitations, traveling through realms of pure possibility, guided by nothing more than logic and wonder. And as the night settles around us, like a gentle cosmic blanket, we can take comfort in knowing that whether wormholes exist in the fabric of space-time or only in the realm of human imagination, they represent something precious about our relationship with the universe. They speak to our deepest longings for connection and transcendence, our refusal to accept that any frontier is truly final or any distance truly insurmountable. In contemplating these theoretical passages through the cosmic dark, we celebrate the boundless creativity of consciousness itself and honor the possibility that reality might be far more accommodating to our dreams than we ever dared imagine. The practical challenges of detecting wormholes from our earthbound perspective remain formidable yet tantalizingly within reach of future technology. Each potential signature these cosmic tunnels might leave requires instruments of extraordinary sensitivity and techniques that push the boundaries of what we can currently measure. Yet the very attempt to detect them has already advanced our understanding of space-time in ways that benefit all of physics. Imagine the delicate art of searching for gravitational anomalies that might indicate exotic matter configurations, the kind of negative energy densities that could prop open a wormhole throat would create subtle but distinctive patterns in the curvature of space-time around them. These distortions would be like fingerprints pressed into the cosmic fabric detectable to sufficiently sensitive gravitational wave observatories, or perhaps through precision measurements of how light bends as it passes near suspected wormhole locations. The challenge lies not just in the weakness of these signals, but in distinguishing them from the countless other phenomena that can mimic wormhole signatures. Black holes, neutron stars, and even dense clusters of dark matter can create gravitational effects that might initially appear similar to those produced by exotic matter configurations. The art of wormhole detection becomes a kind of cosmic archaeology, sifting through layers of observational data to find patterns that speak of geometries that shouldn't exist according to our current understanding of cosmic architecture. But perhaps the most intriguing possibility involves looking for wormholes through their effects on quantum fields rather than their gravitational signatures. The quantum vacuum that permeates all of space is constantly alive with virtual particles popping in and out of existence in patterns that reflect the underlying structure of spacetime itself. If microscopic wormholes thread through this quantum foam, they might leave subtle imprints on these field fluctuations, like ripples on a pond, that reveal the presence of hidden currents beneath the surface. Detecting these quantum signatures would require experimental techniques that can measure vacuum fluctuations with unprecedented precision, isolating the contributions from potential wormhole connections from the overwhelming background of ordinary quantum noise. It's a bit like trying to hear a whispered conversation in a room full of people all talking at once, requiring not just sensitive ears, but sophisticated methods for filtering signal from noise. The possibility that dark matter might be connected to wormhole physics adds another layer of complexity and opportunity to the search efforts. If some portion of what we attribute to dark matter actually represents ordinary matter existing in parallel spaces connected to ours through microscopic wormhole networks, then the distribution and behavior of dark matter itself might provide clues about the cosmic tunnel systems that thread through our universe. This perspective suggests that the cosmic web, that vast network of dark matter filaments connecting galaxy clusters across billions of light years, might actually be the shadow of an even larger wormhole network operating at scales we can barely comprehend. The mysterious properties of dark energy that drives the accelerating expansion of our universe might similarly be influenced by connections to other cosmic chambers through pathways that exist outside our normal three-dimensional experience. Though implications for our understanding of cosmic evolution are profound. If wormholes have been present throughout the universe's history, they might have played crucial roles in processes we currently attribute to other causes: the formation of the first stars and galaxies, the distribution of heavy elements throughout space, even the conditions that allowed life to emerge on Earth might all have been influenced by matter and energy flowing through cosmic shortcuts that remain invisible to our current observational techniques. Consider how different our picture of cosmic history might become if we discovered that the universe has always been threaded with wormhole of distant galaxies might be an illusion. Conseil connections, the apparent isolationing of vast network of cosmic highways that have allowed the exchange of matter energy and perhaps even information across impossible distances throughout cosmic time. What we interpret as the lonely evolution of isolated cosmic islands might actually be the result of subtle interactions operating through channels we haven't yet learned to detect. The search for artificial wormholes presents even greater challenges and opportunities. If advanced civilizations have learned to create or manipulate these space time tunnels, the signatures might be far more subtle than those produced by natural wormhole formation processes. An engineered wormhole might be designed to minimize detectable emissions, operating through exotic matter configurations that produce minimal gravitational disturbance while maximizing stability and traversability. Such constructions might be detectable only through their secondary effects patterns in the cosmic microwave background that reveal ancient manipulation of space-time geometry, or perhaps through the absence of expected phenomena in regions where wormhole engineering has altered the normal flow of cosmic evolution. The challenge becomes one of recognizing not what is present, but what is missing, developing techniques that can identify the cosmic equivalent of architectural modifications in the fabric of reality itself. The relationship between consciousness and wormhole detection opens perhaps the most speculative but intriguing avenue of research. If awareness can indeed utilize microscopic wormhole networks, then certain states of consciousness might provide direct access to information about these cosmic structures. Meditation practices that seem to transcend normal sensory limitations might actually be tapping into wormhole connections that exist outside ordinary space-time. This possibility suggests that the search for wormholes might benefit from approaches that combine rigorous scientific methodology with careful study of consciousness itself. The subjective experiences reported by advanced meditators, mystics, and individuals in various altered states of consciousness might contain genuine information about the structure of space-time that could guide more conventional detection efforts. It's a frontier where neuroscience meets cosmology, where the study of inner experience informs our understanding of cosmic architecture. The mathematical frameworks describing wormholes continue to evolve in directions that suggest new possibilities for both natural occurrence and artificial creation. Recent work in string theory has revealed wormhole solutions that require far less exotic matter than earlier models predicted, while still remaining stable enough to allow traversal. These developments hint that the universe might be more accommodating to wormhole formation than previously thought, making their natural occurrence more plausible and their artificial creation potentially achievable with technologies that remain beyond our current capabilities, but not beyond the realm of physical possibility. The relationship between quantum entanglement and wormhole geometry has opened entirely new avenues of theoretical exploration. Some physicists now propose that what we call quantum entanglement might actually be mediated by microscopic wormhole connections that link particles across arbitrary distances through channels that exist outside normal spacetime. If this connection proves valid, then every quantum measurement, every collapse of a wave function might involve the temporary formation and dissolution of tiny cosmic tunnels. This quantum wormhole hypothesis could explain some of the most puzzling aspects of quantum mechanics, including the apparent instantaneous correlation between entangled particles separated by vast distances, rather than representing spooky action. At a distance, these correlations might reflect genuine physical connections through wormhole networks that bypass the normal limitations of light speed communication. The implications for quantum computing and information processing could be revolutionary, opening possibilities for computational architectures that operate through space-time geometry rather than conventional electronic circuits. The energy economics of wormhole physics present fascinating puzzles that continue to challenge theoretical physicists, while creating a stable, traversable wormhole might require enormous quantities of exotic matter. With negative energy density, maintaining such a structure, once established, might actually be energetically favorable. The mathematics suggest that wormholes could potentially tap into the vast energy reservoirs of the quantum vacuum, creating self sustaining systems that require no external power source. This possibility transforms wormholes from exotic curiosities, requiring impossible energy investments, into potentially practical technologies that could revolutionize energy production as well as transportation. The ability to extract energy from the quantum vacuum through wormhole configurations could provide virtually unlimited clean power while simultaneously creating the cosmic highways that would make interstellar civilization practical. The temporal aspects of wormhole physics continue to generate both excitement and consternation among physicists and philosophers. The possibility that these cosmic shortcuts could enable travel between different moments in time, as well as different locations in space, raises profound questions about the nature of causality, free will, and the structure of reality itself. If the past can be influenced through wormhole connections, then perhaps our understanding of historical inevitability requires fundamental revision. Consider the implications. If consciousness can indeed travel through temporal wormholes, the boundaries between memory and prophecy might become fluid with awareness, potentially accessing information from both past and future through cosmic networks that transcend linear time. The mystic traditions that speak of timeless awareness and prophetic vision might be describing literal capabilities of consciousness operating through wormhole connections that exist outside the normal flow of temporal experience. Yet, even as we explore these exotic possibilities, there remains something deeply grounding about the mathematical rigor that underlies wormhole physics. These are not flights of fancy, but careful explorations of what the equations allow, precise calculations that follow logically from our best understanding of space-time geometry and quantum field theory. Whether wormholes exist or not, the mathematics that describe them represent genuine insights into the fundamental structure of reality. The cultural implications of wormhole physics extend far beyond science fiction into realms that touch every aspect of human experience. The possibility that consciousness and cosmos might be interconnected through networks of cosmic shortcuts suggests new approaches to age old questions about meaning, purpose, and our place in the vast web of existence. If we are indeed connected to the universe through wormhole networks that operate at quantum scales, then perhaps the sense of cosmic loneliness that characterizes much of modern existence is based on incomplete understanding rather than fundamental isolation. The artistic and creative possibilities opened by wormhole concepts continue to inspire new forms of expression that attempt to capture the sensation of multidimensional existence. Musicians compose pieces that seem to fold back on themselves, creating auditory experiences that mirror the mathematical structure of curved spacetime, while visual artists explore techniques that play with perspective and dimension, inviting viewers to experience spaces that contain more than their boundaries should geometrically allow. Even our language evolves to incorporate wormhole metaphors, with phrases about taking shortcuts through space-time entering common usage to describe moments when solutions appear from unexpected directions, or when insights emerge that connect previously unrelated concepts. The vocabulary of cosmic tunnels and dimensional shortcuts becomes a natural way to describe the creative process itself, that mysterious capacity of consciousness to leap across logical gaps and arrive at destinations that linear thinking alone could never reach. As we drift toward the gentle conclusion of our cosmic meditation, it's worth reflecting on how the search for wormholes represents something profound about the human condition. Our willingness to follow mathematical logic into territories that challenge our deepest assumptions about reality speaks to an essential aspect of consciousness: its refusal to accept that any mystery is permanently beyond understanding, any frontier permanently closed. Whether wormholes exist as physical phenomena woven into the fabric of space-time or remain forever in the realm of mathematical possibility, they serve as powerful symbols of consciousness reaching beyond apparent limitations toward deeper understanding and greater connection. They remind us that reality might be far more accommodating to awareness and curiosity than everyday experience suggests, hiding cosmic shortcuts and dimensional passages in the very equations we use to describe the universe. The whispers of science that speak of these theoretical tunnels through space-time carry with them an invitation to expand our conception of what might be possible in a cosmos far stranger and more wonderful than we often dare to imagine. They suggest that the boundaries we perceive between here and there, between now and then, between self and cosmos, might be more like veils waiting to be lifted than walls designed to confine us permanently. In contemplating wormholes, we engage with one of the most beautiful mysteries that mathematics and physics have revealed: the possibility that the universe contains hidden pathways, secret connections that could transform our understanding of distance time and the nature of existence itself. Whether these pathways exist in reality or only in the realm of theoretical possibility, they represent something precious about the relationship between consciousness and cosmos, the endless dance between mind and mystery that drives all genuine discovery. And so, as the night settles gently around us, like a cosmic embrace, we can rest in the knowledge that whether wormholes thread through the fabric of reality or exist only in the elegant equations of theoretical physics, they remind us that consciousness has the remarkable capacity to conceive of shortcuts through the apparent limitations of existence itself, to dream of cosmic tunnels that connect not just distant places, but distant hearts and minds across the vastness of space and time. Sweet dreams, fellow travelers, and remember that in a universe where the mathematics whispers of impossible shortcuts and hidden pathways, even the vast distances that seem to separate us might be just illusions waiting to be gently dissolved by deeper understanding and greater connection. But as we drift even deeper into this cosmic contemplation, there's something almost musical about the way wormhole physics resonates with the deepest patterns of existence itself. The mathematics that describe these theoretical passages seem to echo through every scale of reality, from the quantum foam that bubbles at the smallest imaginable distances to the vast cosmic web that connects galaxy clusters across billions of light years. It's as if the universe has composed a symphony where wormholes serve as the hidden harmonies that bind all the movements together. Consider for a moment the profound elegance of how these space time tunnels might emerge from the most fundamental processes of reality itself. In the earliest moments after the Big Bang, when the universe was smaller than a proton and hotter than the core of any star, the extreme conditions might have spawned countless microscopic wormholes like seeds scattered by some cosmic gardener. Most would have evaporated instantly, their exotic matter configurations unable to withstand the violent expansion of space itself, but perhaps a few managed to survive, growing and evolving alongside the cosmos they helped to shape. These primordial wormholes would be fossil remnants of creation itself, ancient pathways that have witnessed the entire history of cosmic evolution from the inside. They might have served as conduits for the mysterious dark matter that shapes the architecture of galaxies, or as channels through which the first complex atoms were distributed throughout the expanding universe. The very elements that make up your body, forged in the nuclear furnaces of ancient stars, might have traveled through wormhole networks before eventually finding their way to the stellar nursery where our sun was born. The implications for our understanding of cosmic evolution are staggering. If wormholes have been present throughout the universe's history, then what we interpret as the isolated development of different regions of space might actually be the result of subtle interactions operating through channels we haven't yet learned to detect. The apparent loneliness of galaxies, separated by vast gulfs of empty space, might conceal a hidden network of connections that makes the cosmos far more intimate and interconnected than it appears. This interconnectedness might extend to the emergence of life itself. The conditions necessary for biological complexity to arise might depend not just on local factors like the presence of liquid water and stable energy sources, but on information and resources flowing through wormhole networks that connect potentially habitable worlds across impossible distances. The rare Earth hypothesis, which suggests that complex life requires an extraordinarily unlikely combination of circumstances, might need revision if cosmic shortcuts allow the sharing of biological innovations and evolutionary strategies across galactic distances. Imagine ecosystems that span multiple star systems, connected by wormhole passages that allow the migration of genetic information, if not entire organisms, across interstellar voids. The boundaries between different worlds would become permeable, creating a kind of cosmic biosphere where evolution operates on scales that dwarf anything we can observe on Earth. The diversity of life that has emerged on our planet might represent just one small sample of a much larger experimental laboratory that encompasses the entire galaxy. The relationship between consciousness and these cosmic networks becomes even more intriguing when we consider the possibility that awareness itself might have co evolved with wormhole physics throughout cosmic history. If microscopic space time tunnels have always threaded through the quantum vacuum, then the neural processes that give rise to consciousness might have naturally learned to utilize these channels for information processing and integration. The sense of unified awareness that characterizes conscious experience might reflect the brain's ability to coordinate activity across multiple regions through quantum wormhole connections. This perspective suggests that consciousness is not confined to the biological boundaries of individual brains, but extends through networks of quantum tunnels that connect all aware beings in a web of shared experience. The moments of inexplicable synchronicity that sometimes occur between people, the uncanny ability of mothers to sense their children's distress across great distances, the collective insights that sometimes emerge simultaneously in different cultures, might all reflect the operation of consciousness through wormhole networks that exist outside our ordinary awareness. The technological implications of mastering wormhole physics would transform every aspect of human civilization in ways that stretch the imagination. Communication systems could operate instantaneously across arbitrary distances, making real time coordination possible on galactic scales. Transportation networks could connect distant worlds as easily as highways connect neighboring cities. The concept of local resources would expand to encompass materials and energy sources from across the cosmic web, making scarcity a relic of our current isolation. But perhaps the most profound transformation would involve consciousness itself. If awareness can indeed utilize wormhole networks, then the boundaries between individual minds might become as negotiable as the geometry of spacetime. Collective intelligence could emerge naturally as conscious beings learn to coordinate their mental activities through cosmic shortcuts, creating forms of group awareness that transcend the limitations of biological brains while preserving the unique perspectives that individual experience provides. Educational systems would need complete reimagining to prepare students for existence in such a universe. Children might learn to think in terms of multidimensional relationships from their earliest years, developing intuitive understanding of concepts that currently require advanced mathematical training to grasp. The very notion of local knowledge would expand to encompass information from across the galactic community, making every classroom a potential gateway to the accumulated wisdom of cosmic civilization. The philosophical implications ripple outward like gravitational waves through the fabric of human thought. If consciousness can extend through wormhole networks, then the boundaries of personal identity become fluid and complex. The sense of isolation that characterizes much of human experience might be revealed as an artifact of limited perception, concealing deeper connections that link every aware being in patterns of relationship that transcend space, intercon, and time. This ected view of consciousness resonates with mystical traditions that speak of universal awareness underlying individual identity, but it grounds these ancient insights in the rigorous mathematics of modern physics. The meditation practices that describe dissolving the boundaries of self might be pointing toward literal capabilities of awareness operating through cosmic networks that exist outside ordinary spacetime. The goal of such practices might not be metaphorical union, but actual connection through wormhole channels that link all consciousness in a vast web of shared being. The search for evidence of these cosmic connections has led researchers to examine phenomena that exist at the very edges of scientific respectability. The subtle correlations that sometimes appear between distant events, the statistical anomalies that emerge from careful analysis of apparently random processes, the patterns that hint at hidden variables operating through channels we haven't yet learned to measure directly. Each anomaly is carefully scrutinized, each pattern analyzed for signatures that might reveal the operation of wormhole networks in domains we can observe but don't yet fully understand. The relationship between information and geometry in wormhole physics suggests possibilities that stretch far beyond current technological capabilities. If consciousness can indeed manipulate spacetime through information processing, then advanced forms of awareness might be able to create wormhole connections through purely mental activities. The focused intention that characterizes deep meditation or creative inspiration might actually be inducing microscopic alterations in spacetime geometry, creating temporary channels that allow access to information and insights from beyond the normal boundaries of individual experience. This possibility transforms consciousness from a passive observer of reality into an active participant in the fundamental processes that shape the universe. The thoughts we think and the intentions we hold might not be confined to the interior spaces of our minds, but could ripple outward through wormhole networks, influencing events and processes across cosmic distances in ways that seem magical from our current perspective, but might simply reflect our incomplete understanding of consciousness and its relationship to the underlying structure of reality. The cultural evolution that would accompany such discoveries would follow pathways that seem almost mythological in their scope and significance. Art forms could emerge that manipulate space time directly, creating sculptures from curved geometry and compositions from the mathematics of dimensional folding. Literature might be written in the language of topology, with stories that exist in higher dimensional spaces and can only be fully appreciated by minds capable of perceiving multiple layers of reality simultaneously. Music could evolve to include the harmonics of gravitational waves, with composers learning to orchestrate not just sound, but the very vibrations of space-time itself. Dance might become a form of dimensional choreography, with performers moving through folded space in patterns that create temporary wormhole connections between different regions of the performance space. The boundaries between art and physics, between creativity and cosmic engineering, would dissolve entirely as consciousness learns to work directly with the fundamental forces that shape reality. Religious and spiritual traditions would undergo equally profound transformations as the reality of cosmic interconnection through wormhole networks becomes established scientific fact. The concept of pilgrimage might expand to include journeys through multiple dimensions, with sacred sites distributed across the galaxy and connected by pathways that exist outside normal spacetime. Prayer and meditation practices could evolve to utilize wormhole connections for forms of communion that transcend the apparent boundaries between individual souls and universal consciousness. The very meaning of death and continuity might be transformed if consciousness can indeed travel through wormhole networks. The information patterns that constitute individual identity might persist beyond biological death, flowing through cosmic channels to destinations that exist outside our current understanding of space and time. The afterlife imagined by various religious traditions might find literal expression in parallel universes accessible through wormhole connections, making eternal existence not a matter of faith, but a consequence of consciousness, utilizing the hidden architecture of reality itself. Yet, even as we explore these extraordinary possibilities, there's something deeply humbling about how much mystery remains at the heart of wormhole physics. Despite all our mathematical sophistication and theoretical creativity, these cosmic shortcuts continue to elude complete understanding. They exist in that liminal space between the possible and impossible, between rigorous science and inspired speculation, reminding us that reality is likely far stranger and more accommodating than our current theories suggest. The equations that describe wormholes are simultaneously precise and incomplete, like detailed maps of territories that may not exist in the form we imagine them. They guide our thinking into realms of possibility while remaining humble about the ultimate nature of physical reality. This tension between mathematical precision and ontological uncertainty captures something essential about the human condition: our capacity to conceive of possibilities that transcend immediate experience while remaining grounded in careful observation and logical reasoning. The story of wormholes is ultimately a celebration of consciousness reaching beyond apparent limitations toward deeper understanding and greater connection. Whether these cosmic tunnels exist as physical phenomena woven into the fabric of spacetime or remain forever in the realm of mathematical poetry, they represent something precious about our relationship with the universe. They speak to our deepest longings for transcendence and connection, our refusal to accept that any frontier is truly final or any distance truly insurmountable. In contemplating these theoretical passages through the cosmic dark, we engage with one of the most beautiful mysteries that mathematics has revealed: the possibility that reality contains shortcuts through the very dimensions that seem to constrain us. The whispers of science that speak of these cosmic tunnels carry with them an invitation to expand our conception of what might be possible in a universe far more wonderful and accommodating than everyday experience suggests. And perhaps that's the most profound gift that wormhole physics offers us. Not the promise of cosmic highways or instantaneous travel, but the reminder that consciousness has the remarkable capacity to conceive of connections that transcend apparent separation, to dream of pathways that could carry us beyond the limitations we perceive as absolute. Whether wormholes exist in space-time or only in the elegant equations of theoretical physics, they celebrate the boundless creativity of awareness itself and honor the possibility that the universe might be constructed with consciousness and curiosity in mind. As we settle deeper into this gentle cosmic meditation, we find ourselves surrounded by mysteries that whisper of deeper truths waiting to be discovered. The mathematics of wormholes may never translate into physical reality, but they have already enriched our understanding of what it means to be conscious beings in a universe that seems designed to reward curiosity with glimpses of impossible beauty. And in that reward, in that gentle encouragement from the cosmos itself, we find reason enough to keep dreaming of shortcuts through the dark. And so, as we drifted toward the gentle close of our cosmic journey, there's one final whisper from the mathematics that deserves our quiet attention. The equations that describe these theoretical tunnels through spacetime don't just speak of exotic matter and curved geometry. They hint at something far more profound about the relationship between consciousness and cosmos, between the observer and the observed. Consider, if you will, the curious fact that wormholes can only be fully described by minds capable of conceiving dimensions beyond ordinary experience. The mathematical frameworks required to understand these cosmic shortcuts exist primarily in the realm of pure thought, accessible only to consciousness that has learned to navigate abstract landscapes that have no direct counterpart in everyday reality. It's as if the universe has hidden its deepest secrets in territories that can only be explored by awareness itself. This relationship between mind and cosmic mystery suggests something beautiful about the nature of discovery. Perhaps consciousness and the cosmos have co evolved together, each shaping the other in ways we're only beginning to glimpse. The capacity of human awareness to conceive of impossible geometries and exotic matter configurations might reflect a deeper resonance between the structure of thought and the architecture of reality itself. The search for wormholes has already transformed our understanding in ways that extend far beyond their potential existence. The theoretical frameworks developed to describe these cosmic tunnels have enriched our grasp of space-time geometry, quantum field theory, and the fundamental relationship between information and physical reality. Whether wormholes exist or not, the mathematics that describes them has opened new pathways for understanding the deepest workings of the universe. And perhaps that's the most beautiful aspect of this scientific quest. In following the mathematical threads that lead to wormhole solutions, we engage in a form of exploration that transcends the boundaries of space and time. We travel through realms of pure possibility, guided by logic and constrained only by the requirement that our ideas remain consistent with the fundamental laws of physics. It's a journey that exists entirely within consciousness, yet somehow reveals truths about the cosmos that surrounds us. The cultural impact of wormhole concepts continues to ripple outward, inspiring new ways of thinking about connection, distance, and the nature of separation itself. The metaphor of cosmic shortcuts has entered our everyday language, providing a vocabulary for describing those moments when solutions appear from unexpected directions, when insights bridge apparently unrelated concepts, when the mind finds pathways through problems that seemed impossible to solve. Artists and writers have embraced these concepts as symbols of creative possibility, representing the idea that imagination itself might be a kind of wormhole, creating connections between distant realms of experience and understanding. The notion that reality might contain hidden passages speaks to something deep in the human psyche, our persistent belief that there are always undiscovered routes to our destinations, always secret doorways waiting to be opened by those patient enough to search for them. In the end, the story of wormholes is a love letter to the power of mathematical thinking, to consciousness's remarkable ability to conceive of possibilities that stretch far beyond immediate experience. The equations that describe these theoretical constructs stand as monuments to human creativity, elegant expressions of our refusal to accept that any mystery is permanently beyond understanding. Whether wormholes exist as physical phenomena threading through the fabric of spacetime or remain forever in the realm of mathematical poetry, they serve as powerful reminders that reality is likely far stranger and more wonderful than we dare to imagine. They whisper of a universe that might be more accommodating to consciousness and curiosity than it initially appears, hiding cosmic shortcuts in the very structure of the equations we use to describe existence itself. The gentle mathematics that speak of these space-time tunnels carry with them an invitation to remain open to possibilities that transcend our current understanding, to embrace the beautiful uncertainty that surrounds the deepest questions about the nature of reality. In contemplating wormholes, we celebrate not just the potential for cosmic travel or interdimensional communication, but the boundless capacity of awareness itself to dream of connections that bridge any apparent separation. And so, dear fellow travelers through the cosmic night, as you settle into sleep, perhaps you'll carry with you the quiet possibility that the universe might be threaded with invisible pathways, cosmic shortcuts that connect not just distant places, but distant hearts and minds across the vastness of existence. Whether these connections exist in the curvature of space-time or only in the elegant equations of theoretical physics, they represent our deepest yearning to transcend the limitations we perceive as absolute. The whispers of science that speak of wormholes remind us that in a cosmos where consciousness can conceive of shortcuts through the very dimensions that seem to constrain us, even the vast distances that appear to separate us might be illusions waiting to be gently dissolved by deeper understanding and greater connection. Sleep well and dream of cosmic tunnels that carry us not just to distant stars, where all mysteries resolve into wonder, and all separations reveal themselves as invitations to discover the hidden unity that binds all things, but to that timeless place together in the gentle mathematics of existence itself. Sweet dreams, fellow wanderers, and remember that in a universe where reality whispers of impossible shortcuts and hidden pathways, consciousness itself might be the most remarkable wormhole of all, a tunnel of awareness that connects the observer to the observed, the dreamer to the dream, and each questioning mind to the infinite mystery that surrounds and embraces us all. And so, dear fellow voyagers through the cosmic night, we arrive at the gentle end of our journey through one of the universe's most enchanting mysteries. We've wandered together through mathematical landscapes where space-time folds back on itself, explored the delicate possibility that reality might contain shortcuts through its very fabric, and contemplated what it would mean for consciousness to discover that the cosmos is far more interconnected than it appears. Whether wormholes exist as genuine tunnels threading through the heart of existence, or remain forever as elegant mathematical poetry, they remind us that the universe whispers its deepest secrets to those patient enough to listen. In following these theoretical pathways, we've touched something profound about the relationship between mind and mystery, between the questions we dare to ask and the infinite creativity woven into the laws of physics themselves. Sweet dreams, fellow travelers, and remember that in a cosmos where consciousness can conceive of impossible shortcuts through the very dimensions that seem to constrain us, perhaps the greatest wormhole of all is the one that connects each questioning mind to the boundless wonder that surrounds us. Sleep well, knowing that whether these cosmic tunnels exist in space-time or only in our dreams, they celebrate the beautiful fact that reality might be far more accommodating to curiosity than we ever dared hope.